In this video, we are going to see about linear dependence and independence. Definition: let V of f be a vector space. A finite number of vectors v1, v2, etc. vn are called linearly dependent over f if there exist scalars alpha 1, alpha 2, etc. alpha n not all 0 in f such that linear combination alpha 1 v1 plus alpha 2 v2 etc. alpha n vn equal to 0. The linear combination should be 0, but at least one of the alphas should be non-zero. Then we say that these vectors v1, v2, etc. vn are linearly dependent. Now we define linear independence. Same, the linear combination alpha 1 v1 etc. alpha n vn equal to 0, but all these alphas should be 0. Then you say that the vectors are linearly independent. So the linear combination equal to 0 and all the alphas are 0. Then we say the vectors are linearly independent. In short, we can say it this way, like this one, linear combination equal to 0. At least one alpha I should not be 0. Whereas here linearly independent means the linear combination equal to 0 and all alpha i's have to be 0. Other way, in case we are able to form a determinant of the vectors, then determinant A not equal to 0 means it is linearly independent, and determinant A equal to 0 means linearly dependent. Either of this we can use. So now in this sum, we are going to show that three vectors given in RQ are linearly dependent. So we are going to follow this determinant method. So let us consider the matrix with vectors 1, 2, 3 and then 3 minus 2, 1, 3 minus 2, 1. Then the third vector 1 minus 6 minus 5 is written as the third row. So first row, first vector, second row, second vector, third row, third vector. Now for this, let me find the determinant value. Okay, so let us take determinant A. So when I expand, I am able to see that we are able to get 0. So determinant A equal to 0. Whenever determinant A equal to 0, we say that the vectors are linearly dependent. So this is one way of proving. The other way is the row echelon form, where again we can prove that they are linearly dependent. Now here in the next sum, we have to determine x, the value of x, so that three vectors given again in RQ are linearly dependent. We know that three vectors, when we are able to write them as a determinant, then whenever they are linearly independent, then determinant A is equal to 0. So that concept we are going to use here. So linearly dependent it is given. So determinant A equal to 0. The reason is since the vectors are linearly dependent. So now let me form the determinant with these vectors. Let me first pick up the first vector and write it as the first row. Second vector as the second row. Third vector as the third row. And equated to 0. Now ordinary expansion, how we expand a determinant, same pattern we expand the determinant. As we expand the determinant, we are able to get this as x square minus x minus 6 equal to 0. So this will get me the values of x as 3, or it can be minus 2. So whenever x takes the value 3 or the value minus 2, the these three vectors, they become linearly dependent. So either they can ask us to prove by giving values they are linearly dependent, or they will give they are linearly dependent and hence find the value of some unknown given there. Then in the next sum, they are again giving us two vectors and they are asking us to show that they are linearly independent. So here we cannot form a determinant because 1, 2, 3, one row, 2, 3, 1 will be second row. We don't have elements for the third row. Therefore, we are going to follow this procedure. So let me take the linear combination equated to 0 and then show that all the scalars are 0. So let me take A times the first vector plus B times the second vector equal to 0. By saying 0, what we mean is 0 vector. We are in R3. Therefore, 0, 0, 0. Now, write it as the first vector. So, first component I will take, and here it is 2B equal to 0. And now consider all the second components, equate them to 0. Third component, so solving these two equations, I am able to get A0, B0. So in a linear combination equal to 0, whenever the constants A and B are scalars are 0, that implies the vectors are linearly independent. So the vectors 1, 2, 3, 2, 3, 1 are linearly independent. So this is how we prove that